Right, so picking up where we left off after class, a piecewise graph is essentially just more than one graph put together on the same axes. All right, so if we were to look at this one here, we can see that there are 1, 2, 3 different graphs that have been put on that one set of axes. So if we can just quickly look at what the equation of these three things would be, including their domains, remembering that the domain are the x values, the horizontal values that it starts at and finishes at. So this blue one, the equation, I'm just going to take straight from here. It is y is equal to 12 minus 2x. That's the equation of the graph. And the domain, or the x values, it starts at -2 and it ends at +2. So the way I can write that is -2, I'll put a comma here, that's the less than symbol, x less than symbol +2. And what that means is it goes between 2 and -2. Right, if we then look at the orange one, change color pens, the orange one, the equation, again copy direct, y is equal to 1/2 x, so the gradient's 1/2, plus c plus 7, and that goes from 2, the x value, so the domain, to x and up to 10. And finally the green one, the equation, start by writing it, y is equal to 52 minus 4x, and then the domain, the set of x values, starts at 10 and finishes at, what's that number down there, 13. So that's what the equation of this piecewise graph would be. Those would be the three things, three different components made up of that equation. If we're to sketch one ourselves, what we need to do is sketch each of those two things. Now this domain looks a little bit different, and what we said in this last slide was that if we had a less than or equal to symbol, it would be a closed circle. And so in fact I'd need to see here that this is a closed circle. A closed circle is one that's been coloured in. An open circle is one that has not been coloured in. So because all of these are closed circles, I should in fact have the or equal to sign on all of these because they're all closed circles. That one's a closed circle and that point relates to here because it starts at 10. I'll make that clear in the next one. So here we're going to sketch our graph. We want to sketch each one of those two things in those different domains. Now I'm going to start by labeling them, number 1 and number 2. I'm going to say sketch 1. Now earlier in the slides we looked at sketching graphs. It's exactly the same, except we only want to sketch this one for the x values that are less than or equal to 1. Alright, so sketch number 1. And what we need to do, we know the y-intercept is +1, so sketching we need 2 points. 2 points. We always need 2 points when we're sketching. Point 1 is going to be the y-intercept, +1. So I'm going to put a point there. Here's my first point. Point 1 is the y-int, which is +1. And then the gradient, I'm going to use the gradient for point 2. For point 2. And now the gradient is equal to 2. Now remember I rewrite that as 2 over 1, means I rise 2 and run 1. So rising up 2, 1, 2, and running along 1. So there's my second point. And now I want to draw that graph, and I can't do it so well with this pen, but you guys need to rule it. Draw that graph there, and that should extend the whole way. So now sketch 2. Let's even change colour so it can be nice and clear. Let's put it in red. That's number 2 there. 2 points, always 2 points when we're sketching graphs. First point is from the y-intercept. C is equal to -1. And then point 2, so I can put that on, C is equal to -1, that goes down here. That's the y-intercept, -1. And point 2, we're going to use the gradient, gradient for that one is 4, so m is equal to 4. And I'm going to rethink of that as 4 over 1. So rising up 4, 1, 2, 3, 4, running along 1. What happens to be the exact same point as before. So now I sketch that one as best I can with this lack of ruler. And now I'm kind of done. See, the thing we haven't taken into account yet is the domain. So for the red one here, we've got to look at that one to start with. The red one, the line only exists when we're going greater than 1. Okay, so when x is 1, that's here. So everything on that side will have the red line for. So what I need to do, I'm going to grab out the rubber. And I don't care about anything on the left-hand side of the point 1, because this is x is greater than 1. So everything here is good, everything here is no good. So for the red line, let's get rid of that. And even that little bit there. Oh, don't want that. That little red bit gone. So that's the only bit we care about. And now because it's x is greater than, and not greater than equal to, only greater than, we need a open circle. And that will just continue on forever. If the page is longer, it would extend up. Alright, so for this second one, we want to use this equation. I've done this out of order, but that should be okay. So this equation is being drawn when x is less than or equal to 1. So where is x less than or equal to 1? X is equal to 1 here, so anything less than that. So anything this way is good for the stuff that we have in green. So this section, the green section, shouldn't be existing where x is greater than 1. So I'm going to rub out that bit. And now we've got a step graph, kind of hard to see a little, but up to there and up to there. Green less than 1, as it says, red greater than 1. Moving right along. Step graph, very similar. Okay, so a step graph is more or less the same thing, although in a piecewise graph, it's formed by putting 2 or more graphs together. It's continuous and there are no breaks in a piecewise. In a step, the difference is that a step will be straight, there are straight lines only, and they can have, or they have zero gradient, and they can have gaps in between them. Okay, and again, this is where these circles are going to come much more into play, whether it's an open circle or a closed circle. So let's just have a look at a quick example, and when we're done. So we're going to construct the following step graph. Y is equal to -2, so there's no gradient, which just means it's a straight line, when x is less than -2. So where is x less than -2? Well, let's go find -2. -2 is here. And when x is less than -2, so that's everything in this direction, everything down that way, from -2, which is that line there, to everything that way, we're going to have the line y is equal to -2. Y is equal to -2, that's where y equals -2, so from this point backwards in a straight line as I can, that's what that part would look like. So when x is less than -2, there's x is less than -2, y is equal to -2. So let's just change color. Oh, except we need to take into account this circle here. So that circle there is going to be an open circle. It's hard to draw, but I'm not going to color it in. Okay. The next one is between -2 and 3. Y is going to be equal to 1. So let me just change color. Y is equal to 1. Where's y equal to 1? There's y equal to 1 there. And between -2, between x is equal to -2, so -2 on the x starts there and finishes at 3 there. -2 to 3, we want to have y is equal to 1. So I'm going to draw a line -2 to 3, and next to the -2, I'm going to have an open circle because there isn't the line there. So that one would be an open circle. This one, however, will be a closed circle because when the x is near the 3, that one indicates a closed circle. Now this last one, when x is greater than 3, y is equal to 4. And that's going to be a closed circle there. So let me just change color one more time after I show you that the green one is the green line. change to, I don't know, orange, and I love orange. Y is equal to 4. So where is y equal to 4? That's y is equal to 4 there when it's greater than 3. So there's x3, it's going to be going in this direction, and put an arrow there to say that it's going to keep going, and a closed circle. There's my closed circle there. Okay, so those are step graphs. Say that is orange. The last thing is modeling with piecewise and step graphs. So we've done a bit of modeling. We know piecewise and step graphs. This question's relatively straightforward. We're going to construct a step graph based on the following information. So if you stay in the car park, between 0 and 1.999 hours, so almost 2, it'll cost you $1. So what we're going to do here, I'm going to change this. So this is dollars. And this is T for time, and that'll be in hours. Okay, so this first one, if it's between 0 and 1.9 hours, so when the time is between 0 and 1.9, it's going to cost us $1. So the cost is $1 if I stay between that period of time. Right, I'm going to include this circle. If I stay, even if I get in and get out straight away, it's still going to cost me $1. This one here, however, it comes up to 2, but it doesn't include 2. It's 1.99999. So I'm going to have an open circle there because it does not include the number 2, even though it gets very, very, very close to it. Between 2 and 3.99 hours, and that does include 2, it ends up being 250. So 250, it's a little hard to draw. But between 2 and almost 4 hours, it's 250. So that's 250 there. That will be a closed circle because 2 is included. But is 4 included? No, it almost is, but not quite. So that one's now done. We now need to go between 4 and almost 6 hours. So between 4 and almost 6 hours, it's costing us $5. So between, where's $5? $5 is here, the cost. Between 4 and almost 6, that one does include 4, so I'm going to have a closed circle because it does include it, and an open circle where it doesn't include it because it almost includes 6. And then 6 plus, it costs us $6. So from there onwards, it just keeps going. If I stay for 48 hours, apparently it's going to cost me $6 still. I doubt it, but you know, that's what this info says. And it does include 6 hours. So there's a piecewise, sorry, that's a step graph, not a piecewise. A piecewise doesn't have these gaps in it based on this particular scenario there. Right, there's our chapter 10 revision done. Good job.